Yo, what up, guys? What up? What up? I am Liu, guys. It's been a while, man. It's been a while. It's actually been a couple of weeks. There's a lot of things happening, guys. That's kind of the reason why you haven't seen a video maybe in the last week or two. My live stream kind of got put on pause for now that I do every Friday. So I'm rechanging the schedule. I'm going to bring back the live stream soon. Just a few things I need to rechange. I'm going to have the schedule changed differently. There's just a lot of things going on. Finally became Twitch affiliate, so I'm working. There's things that I'm working on that platform as well. So there's a lot of good things going on, right? But nevertheless, I'm doing a rescheduling on my live stream, so be on the lookout for that. And we'll get back to the live stream pretty soon. But in this video, guys, this is a multi-part video that I'm making of comparing Microsoft SQL Server and Postgres. So for me, those are the two databases that I use very heavily. I use other ones too, but without a doubt, these are my two main ones, right? So this is kind of where I'm providing my 2 cents, my feedback of differences, right? I'm not necessarily comparing what's the same. I'm trying to compare on what's different between the two. And before we get started, guys, you could hit that like button, give me a follow, man. I appreciate it. Go ahead and hit the like button, guys, and let's get started. All right, guys. So I already have some SQL syntax in place for us to kind of review. What I kind of did this up front because I want to just kind of go through and we're going to just compare the two, right? And I'm going to kind of explain some details behind certain pieces of it. So, for instance, so everything on the left side is SQL Server. You can tell up here, SQL Server, again, which is Microsoft's database, their version. Then you have Postgres on the right side. The first thing I'm going to look at is how do you create procedures when in these two databases, because they're not the same. Even though the concept is the same, but the syntax it's different, right? So that's kind of where I want to touch bases on what's different. So in this case, we're going to create a procedure that takes no parameters. So keep that in mind. I am going to be showing examples in the next video of procedures with parameters, but in this case, no parameters. In order to create a procedure in Microsoft SQL Server, it will be create procedure. And then it will be the schema, like where do you want this procedure to live? Like which schema of your database. So by default, we're going to, specify DBO schema. And then we have the name that we're going to specify, right? In this case is USP, then the name of the procedure. So here's some things. And I want to make sure just kind of everybody's clear. There's a lot of languages or even database or whatever let's say in this case databases, but even other programming languages and so forth, you have certain ways of doing things, right? Like kind of give an example, some languages use camel case for certain assignment of like functions and things of that nature or classes. Others do not, but at the end of the day, it really doesn't matter, right? You could just name everything, have everything uppercase, have everything lowercase, but those communities have built certain standards. Well, there are some standards that you'll find in the SQL community, and for example, at least through my experience of working on different projects that happen to be SQL Server database, I noticed a lot of these people that have worked on these databases before implemented these same patterns as well. So anytime you create a procedure, again, you don't have to do it this way, but if you want to kind of follow certain patterns that other people are doing, you'll see that a lot of the time the user would start their procedure name with USP, which is user store procedure. When you look at a SQL Server database and you look at procedures that are created by the system, the database itself, they start with the SP, which represents stored procedures. But anytime you see an SP only, it's that lets the user know, like me or anybody else, that those are stored procedures that were created by the SQL Server, right? You know, they're part of SQL Server. They're not created by any external users. They're built in to the database. So that's why anything that has a U in front of it means a user stored procedure. Like me being a user, I created it. It's not part of the database itself. So these are the certain patterns. And of course, after that, you specify whatever the naming is. You know, a lot of times you specify what is it doing, right? In this case, it's rebuilding cells. You know, rebuilding sales table or whatever. But you know, you specify some details of it. But again, at the end of the day, keep in mind, if I were to remove this and just call it rebuilding cells, it's going to work, right? It's not like it's not going to work. It is going to work. But there are there are certain ways of doing things that as you are, if you see how other database developers, you know, build, you know, their procedures, you will find a lot of these patterns, right? So just want to let you know. So after you specify the create procedure statement, and then it's the schema, then the name of the procedure. After that, it's going to be as, and then you specify begin and end. So anything that's in the middle between the beginning and end is what's going to execute, right? You could do all kinds of stuff. You could delete, truncate, insert, update, whatever, right? There's so many, there's a lot of things you could do. There's stuff that you could do where you have what you call a procedure. It returns back a table, for example. There's things. Normally you would kind of, that's a different type a function that you would end up implementing. And again, I will go through that in a later video. But what I'm trying to say is there's so much that you could do here. This is where you could add a lot of business logic to do maybe some iterations of something, to update some values before it gets inserted to the table, or do whatever it is, right? But in this case, what we're doing a truncate. So we're truncating, in this case, it would actually be the DBO. So we're going to truncate the DBO table, and then we're going to do an insert, because again, by the name says is rebuilding sales table, or cells, which is the sales table. So we're going to truncate table. They're going to reload from a staging table. That's all we're doing here, right? Very basic, but at least you get the concept of when it comes to creating a procedure, this is where you're really focused on. You got your statement, create procedure, schema, specify the name, and then it'll be as, and then begin. Anything between begin and end is pretty much what your procedure is going to do. If we look at the Postgres version of this, very similar, but of course the difference is our statement is, it's not just create procedure, which you could just remove this and it will create the procedure, that's fine. But this is create or replace. And again, it does replace if it already exists, which I like that, because in SQL Server, you would have to change the create to alter if you wanted to update the procedure, right? Where in this case, you could just have it all in one and it automatically would do both create or replace, which is the equivalent of alter or update. Same concept, right? Specify your schema. In this case, it would be a public schema. You know, DBO is the standard schema that your database comes with on a SQL Server database. Public is your standard schema that comes with the Postgres database. Just keep that in mind. And then we're going to call it. Now, in Postgres, you don't see that pattern, the USP underscore pattern. You know, that's not a pattern that necessarily exists for Postgres. It exists for SQL Server, but not for Postgres. So in this case, it would just be called rebuild cells, and then you have open and close parentheses. Keep in mind, there is no open and close parentheses over here, but there is over here, right? The only time you have open and close parentheses over here when you're passing in parameters. In this case, it's open and close, but there is no parameters. It's blank. If we are passing in parameters, then there will be something in here, but nevertheless, you gotta specify open and close parentheses. And then you get to the language. Again, there's no language over here. Over here by default, it is running the T-SQL language. T-SQL is the procedural language that exists for SQL Server. A lot of these databases have their own procedural language. Think of it as your own programming language, right? That's specifically for, like Excel, has built-in VBA. You could use that language to do some stuff in Excel, for example. In the database, it has a procedural language. And in this case, it's called T-SQL for SQL Server. And for Postgres, it's called PL/PG/SQL. Now, one of the things that's cool with Postgres is you could have other languages, like you could install Python, for example. What's the other language? I don't think Ruby, but there's a few other languages that you could actually have installed, and you could actually run. So inside the but let's say you specify Python, for example. Then there's some configuration and things you got to set up inside your begin statement, right? Same thing as in SQL Server. You got begin and end. You could actually write Python code in here to do whatever it is you're trying to do. But again, is some setup involved that you have to do to make that work. By default, though, we're not doing that. We're using the procedural language that comes with Postgres and that comes with T-SQL. So we got to specify what that is, which is PL/PG/SQL. And then we have as, and then of course after that we have in $ procedure. And then we have our begin statement. So you could tell there's a few more additional things that needs to be set up compared to a SQL Server with literally just as and begin, you're good to go. This one is language, as, then procedure, and then it's begin and end. And then of course you have your same statement. In this case, our code is pretty much the same here. Truncate is the same. One thing to keep in mind, in SQL Server, you don't have to do this. After you finish a statement, you don't need to put a semicolon at the end. In Postgres, it's known to do that. That is, again, part of the best practice. After you finish your statement, you put a semicolon, and then and you do that after each statement, right? As you could tell, I'm doing it after each statement here. So, but this is the same. Insert the same. Select the same. Only difference is the schema right here. This would actually be DBO. But, yep. My bad, not DBO. This would be public, because it's a public schema. So we would truncate and then insert. So a lot of this is the same, but the way you create your procedures different. You could tell. And these are some of the differences. So once you create your procedure, the next step is, okay, well, I need to execute the procedure. How do I run it? Right? So now let's go back to the next. Let's compare those two. And we're going to look at execute procedure. So the same procedure that we just created, in order to execute it, this is how you will execute it. You will call the execute statement, schema, then the procedure name. Right? Pretty straightforward. Execute, schema, and then the name of the procedure. In Postgres, it's not called execute. It's the call statement. So it would be call, again, schema, procedure name. Then you also got to specify open and close parentheses, right? So this is one of the big difference. Besides the execute and call statement, at the end of your procedure, this one does not have any open and close parentheses, but in Postgres it does. So you got to specify that, because it's not going to run. It's going to error out. So again, these are some differences on when it comes to executing the procedure. So next, let's look at when it comes to declaring variables, right? I want to look at that. When it comes to declaring variables, what's the difference? In this case, we're going to declare two variables, a integer and a varchar. So in SQL Server, it would be declare. Then you have the @ symbol here, @ and then the name of your variable. And then you're going to specify the data type. In this case, it's going to be an integer, int. And then it's going to be equals whatever value is going to equal, right? In this case, it's 13. Now, if we look at the equivalent of Postgres, we'll see that it's kind of similar, but it's kind of different too, right? So we do have a declare statement. Now the difference here is we don't have an @ symbol in the front of our variable. It's literally just the name of the variable. Right over here we have an @ symbol. Over here you do not. So you got to be careful here because there is no at symbol. You got to make sure if you're declaring some kind of variable that this variable does not already exist as a column name somewhere. Or if it does exist, you're very specific that when you use it in any select statements that your column name that happens to be the same name as your variable, that for the column name you specify some kind of alias name of the table or the table name itself. So, but ultimately try to keep it unique if you can. And then you specify integer, so you spell out integer. Now you can tell the equal sign instead of just being equals in this case is it's not the case, right? So it's slightly different when it comes to assigning your variable. But besides that, it's pretty reasonable, right? They're pretty much very similar, nothing too different. And then we look at a varchar. Varchar, again, same concepts, but everything else is the same. Even the varchar 100, varchar 100, same. There's no issue here. Now there is a different value in Postgres. Varchar works, but there is what's called a character data type, and you could specify that, which is like a variable character. I believe that's what it's called. Nevertheless, though, you could use varchar and it'll work the same. But again, this kind of at least gives an example of comparing declaring variables in SQL Server and Postgres. And the next thing we're going to talk about is conversions. So let's say we're converting a string to a date. Now, there's two ways to do it. I mean, there's more than two ways, but I'm showing you two ways in this case. One of them is going to be kind of important, and I'll explain why it matters, right? But let's look at the ways to do it real quick. In SQL Server, there's this convert function. And then the convert function, the way it works is, you got your select statement, then it will be convert. And then the first argument in the function is, what do we want to convert the string to? Right? In this case, we want to convert it to a date. Now you can convert it to anything. You can convert it to integer, a varchar, doesn't matter. But in our case, we want to convert it to a date, and that's what we're specifying because the first argument is data type. What are you converting it to? And then, of course, the second argument is, again, I hard coded in the date as a string, but realistically, it would be the name of your column. Let's say you're dealing with something like sales date. That's what it would be, right? It would be sales date in that case. And that would be a way to convert your string, if it happens to be a string, to a date. Or a better example, let's say you have a column that's date time, right? Kind of going back, let's say this column here, this is probably more realistic. You have what's called sales date time column, right? Because they have the time in it, but you don't want the time. You just want to have the date only. Then that's where this will make sense. You convert it, and you're going to convert this sales date time to a date format. So the time gets stripped out, and now you just have date only. Now the way you do that in Postgres, I think it's a lot easier. You literally would just specify. You would just pretty much determine right after your variable, or right after your column, right, or in this case the string, what variable, what data type you want it to be. So in my case, it would be a date, or it could be something else, right? It will be date for Postgres, but if you're dealing with date time, it would be timestamp, right? It's not date time in Postgres; it's called timestamp for date time. So the data type in SQL Server is date time, in Postgres it's timestamp. But when we're dealing with date, they are both date, right? So date's the same, but when it comes to date time, it is different, right? Just keep that in mind. And again, this would be your actual column, right? The same thing as the other one. It would be like sales date time. Let's say that was the name of your column. This is what would convert it to a data type, right? So I like this approach. Real clean, very simple, easy to implement. I prefer that approach. Now, there's another option. when it comes to converting to a data type. You could use cast. Now, cast is one of those functions that actually exist in many other databases, right? Not just Postgres and SQL Server, but MySQL, and the list goes on, and potentially other many other databases. It's a very old school function that's been around for years and years, and that I think that's the reason why it exists so many databases, because it's been just one of those things that kind of built in and everybody implemented it into their database. Um, here's where it becomes very beneficial to use something like cast, because it is a conversion that exists for many other databases. So let's say you have this select statement that you're running on your side, and there's some sort of, let's say there's some migration where the data being migrated over from Postgres to SQL Server. Well, if you have a select statement that maybe is doing some conversions, converting the your your, let's say, date time or your string to a date, in your view, for example, you could most likely just take that view and run this and create that same view and execute it and run it without any issue at all by using this cast function, because it exists already on multiple databases. If you were to have this part of your view to convert it a date time to date, what happens is that view, if you were to take that view and try to now, let's say, copy it over to a SQL Server database, it's going to error out. It's not going to work, because this does not mean anything to SQL Server. It's going to be an error. But cast, it knows what it is. It works on both SQL Server and Postgres. Because it works on both, there are certain functions like this where it makes your statement easily transferable to other databases. So again, it's one of those deals. A lot of the time when you're working on databases, you're not thinking, oh, I'm building this new database and we're using SQL Server, but next year we're going to switch to Postgres. You normally don't do that. I mean, because if that's the case, you might as well just start building in Postgres, not in SQL Server. Nevertheless, things happen sometimes. Maybe you see the cost too expensive in SQL Server, and you want to go with the open source license of Postgres, which is cheaper. I mean, there are different reasons why you will make the switch for one or the other. Nevertheless, though, just keep in mind that some of these functions are not transferable, but something like cast is. So if you want to be very focused on, I want my code to be as much as possible transferable to any other database as possible, then try to make sure to find certain functions, like cast is one that actually exists for both Postgres and SQL Server and Oracle, and the list goes on and on of other databases. So hopefully this kind of gives you some insight to that, and a little bit more better understanding of the differences of these two. Again, guys, man, I know it's been a while. It's been like 2 weeks or so since I have actually made a video, but I'm making a lot of videos, man. So you're gonna see a lot of videos dropping the next couple of days for sure from me. There's a lot of things happening, a lot of things in the works that you're gonna start hearing about more and more. But nevertheless, guys, it feels good to kind of be back. I'm gonna be making a lot more videos, so hopefully it helps y'all out. Let me know y'all have questions, guys, and y'all take care. Peace.